Hey everyone, welcome to the sixth week of HPC in the cloud. I'm Joe Schoonover from Fluid Numerics out here in Boulder, Colorado. And today we are going to be talking about how to run OpenFoam on Google Cloud Platform. Just a couple things to get us started here. If you do have any questions at any point during the tutorial, feel free to post them in the chat. And of course, subscribe to our channel so you can keep up to date with all the latest things we're going to be showing you in the coming months. Before we get started today, there are a couple of prereqs if you wanted to follow along with the demonstration. Everything we're going to be doing is going to be done on Google Cloud. We're going to be using an auto-scaling HPC cluster on GCP. So if you don't have an account already, go ahead and create one. Go to console.cloud.google.com. Just use your Gmail account or a G Suite account. If this is your first time signing up, you'll be able to get $300 trial credit that you can use towards today's tutorial. You should expect that if you're just doing what we're doing today, you shouldn't be spending any more than $5 to $10 to get through what we're going to do today. And the other side of it is you will want to make sure that you have sufficient quota. You will need at least 24 virtual CPUs and about 120 gigs of disk space to get through the demo today. All right. So in detail, what we're gonna cover is I want to give you two strategies on running OpenFoam on GCP. One, of course, you can use an image that we've made publicly available that's out there. That's the quickest way to get started. But we did want to kind of give you a little bit of a background on how these images get created so that if you have other applications or maybe if you want to do customized builds of OpenFoam, maybe a different MPI flavor, different optimizations, what have you, we're going to walk through how to use HashiCorp's Packer with Google Cloud Build to create your own custom VM images. And then, of course, along the way, we'll show you how to use your own custom images on an auto-scaling HPC cluster. So the first thing we're going to do to get started, of course, is get that cluster off the ground. If you're on Google Cloud already, if you look on the top left of your screen here, I'm showing the GCP console. We're going to start just by going to that Products and Services menu on the top, the triple bar menu there, and navigate down to Marketplace. So you should be able to navigate, search for Fluid Slurm GCP or Slurm GCP or Slurm. You'll find us there in any place. Go ahead and just use that top solution there. This is a CentOS 7 based auto-scaling HPC cluster, and we'll go ahead and hit launch. So today I'm just going to be doing a quick start. I won't be going over details on how to launch this cluster. We did do a tutorial on this a couple weeks ago. If you look back through our channel, you'll be able to find some of those videos there for more details on what's going on here. I'm just going to go ahead and configure this cluster and get it launched. So we're going to call this deployment OpenFoam. I'm going to set the zone as US West 1. I'm just going to go with a lot of the defaults here. If you're going for a production system, generally we recommend at a minimum of 8 virtual CPUs just so you can get past this network egress caps that you have when you're below 8 vCPUs. Usually you want to have about 16 gigabits per second so that your file I/O and other activities aren't inhibited. Just for the demo today, I'm going to leave everything at 4 virtual CPUs on both the controller and the login node. And then down on the compute node, for the demo we're doing today, we're essentially going to be running the one of the tutorials. It's the incompressible solver. We're going to be doing flow over the NACA 12 airfoil, and I've set it up so we can do a parallel run with MPI. And you'll need at least 8 vCPUs for that. So I'm going to go ahead and select here the N1 standard 8 system, and let's call that Partition that we're going to run on OpenFoam. The other thing here, you're going to need a boot disk size about 50 gigs, and that's because when we go to switch to the custom image that we're going to build, or if you're using our provided image, you will need at least 50 gigs on the disk that's mounted on that compute node. Once you're done, go ahead and hit deploy. So what's happening in the background here, once you go through Marketplace, is Google will launch what's called Deployment Manager. It will create a controller node that's going to host the Slurm job scheduler for you, and a login node that you will typically use to hop into that system and interact with the Slurm job scheduler, submit jobs, etc. So out of the box, we're not creating any compute nodes. Those will be created on the fly as you submit workloads, and you'll see that in action when we get to running OpenFoam. So we're going to let this set up in the background. This takes a couple minutes, but while that's going, we're going to go ahead and kind of walk you through how to bake your own virtual machine image. that you can run on this cluster. So you can do this in one of two ways. If you have the gcloud SDK already installed on your own system, you can follow along in your own terminal. If you don't have the gcloud SDK, that's all right as well. You can just use the Cloud Shell. So on the top right of the Google Cloud Console, you'll see a icon that looks like a shell. I'm hovering over it and it just says Activate Cloud Shell. If you hit that, that will open up a terminal in your browser, and you can use that. That will have gcloud, Git, and all the tools you'll need to actually follow along. So if you don't have gcloud locally, definitely use that Cloud Shell. It's a good place to follow along. All right, so next thing we're going to do here, we provided a repository for you that has a few templates that you can use with Google Cloud Build and with Packer to create virtual machine images. So we're going to go ahead and clone that repository. Now, I've already cloned it on my system, but you can see the link there on the slides. And then, of course, on your local system or in Cloud Shell, just go ahead and set the GCP project using gcloud config set. I'm going to go ahead and set mine. Make sure I'm in the right project here. So I'm doing Cloud HPC Demo. So there we go. All right. So underneath that repository, there is a directory called examples, and underneath that, you'll find OpenFoam. And what we provided for you in here is a cloudbuild.yaml, which essentially outlines the steps that Google Cloud Build needs to build the image. So let's take a look at that. So if you haven't used Cloud Build before, essentially you're driving this whole system through a YAML dictionary that basically lists out the steps that it takes to build an application. So here we just have one step, and we're going to use HashiCorp's Packer we're going to pass through it this packer.json file, and this packer.json file has all the instructions necessary to create a virtual machine on Google Cloud and execute a startup script. In our case, the startup script is going to install OpenFoam and its dependencies, and then it has some details on what we name that image. Now, when we're done, essentially you'll end up with an image in your GCP project called OpenFoam GCP. Okay, and if we I'll take you a quick tour through the startup script. What we have going on inside of here is it sets up the GCC 9 dev tool set on CentOS. So you have basically GCC 9 compilers. We just set up CMake, OpenMPI version 4, and then down below we go through the standard OpenFoam install from the OpenFoam dev repository. So that's pretty much it on that repository. If you go back to that root directory on that demo repository, we're going to basically run Google Cloud Build from here, and we'll pick up from there. Okay, so to build that image, you'll just run gcloud build submit. Give it the current path, and then in terms of the configuration file, we're going to tell it to use the cloudbuild.yaml that's provided underneath that example directory. Now, if you did want to end up using all this stuff as a jumping off point for building any of your other applications, maybe you want to actually install ParaView, which, surprise, in a couple of weeks we're going to have a ParaView tutorial for you as well. So, all right, so we'll do config equals examples, OpenFoam, cloudbuild.yaml. And we're going to let this run. Now, if you've installed OpenFoam before, you know this can take a while. And the way we've got it set up is basically what's going to happen is Cloud Build's going to use Packer to create an N1 standard 16 virtual machine on GCP, and it's going to load that startup script up there to run and install OpenFoam. That whole process, even with the parallel build, it takes about an hour and 15 minutes to build. Which is why we did offer a publicly available image that's just easy to use. You don't have to go through this build process, but we did feel like it was going to be useful for a lot of you who have other applications that fit your entire workflow when you're doing your fluids modeling. You might have mesh generators, who knows. So we'll let that run. I did just want to give you a quick tour of the Cloud Build panel here, and then we'll get back to get onto our HPC cluster and launching the job. So if you go to that products and services menu and you scroll down, now I've got Cloud Build pinned up here. You'll probably find yours down underneath tools. Go to Cloud Build, and this will bring you to the Cloud Build dashboard. Basically you'll be able to keep track of what's going on with that installation. Just like you saw in the terminal, we have all this log output that's happening. You'll also have that showing up here. In addition, you'll have execution details. Now, we don't have any build artifacts like that are tracked by Cloud Build. Instead, those build artifacts are actually tracked underneath Compute Engine. And the reason why that happens is because everything that Packer does underneath the hood really is tied to Google Compute Engine's API. So you can see we've got this OpenFoam GCP image node. That's what got created during the Cloud Build process. Essentially, that node is what's running through the OpenFoam install, and when it's done, Packer will tear that down and post an image on your Google Compute Engine images. Okay. So if you click through on images, you can see I've done this before. And mine's named a little bit differently. Yours will show up as OpenFoam GCP if you're using the most recent version of that repository. And what you're going to need if you wanted to use your own custom image to keep in mind is if you click on that REST link on that page, again, that's down here, equivalent REST, scroll down and you see we've got this self link. This self link is what you're going to need to substitute into your HPC clusters, what we call a cluster configuration file, in order to drive compute nodes with those new images. So keep that link in mind. Otherwise, when we actually go to launch, oh, looks like my console disappeared here. Let me get that back up. Whoops. There we go. All right, sorry I didn't see how long back that cut out here, but let's just go back here real quick. So if you're looking down at the Compute Engine panel, down on images, the equivalent REST, there is a self-link variable. That self-link variable is what you're going to need to use for your Compute Engine instance settings in order to run. Of course, like I said, we do Fluid Numerics does have a publicly available image that you can also use for this demonstration. Okay, so let's get back to the deployment manager page. Once your cluster's actually been deployed, you'll see you have a page that kind of looks like this. It says FluidStorm GCP, and now we've got a login IP address and a controller IP address. Now there's two ways you can actually SSH into these nodes. So one, you can go from the Compute Engine user interface. You'll notice there's an SSH button next to the controller. If you want to SSH in that way, that's perfectly fine. Just make sure you're hopping into that controller. So click that SSH button to get in. I'm going to go ahead and log in from my terminal. So if you have OS login already configured, that'll be fine as well. So let's go ahead and hop in. Now this is your first time SSHing into a virtual machine. Especially if you're doing this from your terminal, your Linux username will be a little bit weird. Essentially, it's going to be your email address, except the @ symbol and the dots will be replaced with underscores. Okay, so now what we're going to do, and now my terminal's disappeared, so let me get that back. What's going on today? Okay, now we're looking good. Okay. All right, so the next thing we're going to do here is we're going to update the compute partition image. So the way this this auto scaling cluster works is it has what's called a cluster configuration file that dictates all the mounts that are available, the Slurm accounting that you have on your system, and then the types of compute instances that are available for you to submit jobs to. So when you first get on there, if you're familiar with Slurm, you might already be poking around. The sinfo command will tell you what node you have. And right now we just got a compute partition called OpenFoam, and it's got 10 nodes in there, OpenFoam 0 through 9. And if you remember back from when we set this up, these are all just N1 standard 8 instances. Now, to change the type of instances or change the virtual machine images that are used to launch those compute nodes, you basically need to customize that cluster config. So we're going to do that using a command line tool that we provided for you guys on this system called Cluster Services. And to run that application, you do need to go root. So go ahead and run sudo su, go root, and then we'll run Cluster Services list all. We'll list the current cluster configuration that's there. So we're going to take that and we're going to put it into an output file called config.yaml. So if we open up config.yaml, there's a lot of things in there, but in general, what we need to focus on here are compute image, so that's one spot. Let me go ahead and set the numbers here. you can either swap out the image here, which would set all the compute nodes would basically be using that compute image unless you specify one down in the partitions. So if you go down to partitions starting at line 21, down into machines in line 24, within that machines block, you can actually add an image specifier, and then you can put that self link for the image there. I'm going to go ahead and just use the one that we published for you guys. If you want to go ahead and get started quickly, that's a good way to do it. So just go to project. You'll put projects, fluid cluster ops, and global images, and OpenFoam GCP. Okay. You know, basically all this does is gives you access to a lot of the tooling we've already provided for you with the auto scaling clusters, so you don't have to worry about, you know, making sure your home directory is mounted, apps directory is mounted, all those other things. You don't have to worry about making sure the Slurm daemon is going to be communicating with the Slurm controller. Like it's already done for you. So it should make this process pretty straightforward for you. If you did want to change that machine type at any time, of course, you can come in here and you can see we've got the N1 standard 8 populated there. So like if I wanted to change it to N1 standard 16, no big deal. So that's about it. That's all you really need to do to get started with OpenFoam. So let's go ahead and apply those changes. So we usually recommend doing this in 2 steps. We're going to run cluster services update partitions. We'll give it a we're going to use the config file that we just modified to do the update. And at first, we're just going to preview those changes. So if you ran preview, you see what it detected is, hey, we're modifying that machine type. We're changing it from N1 standard 8 to 16. That's just, I just felt like doing that there just to demonstrate that for you. And then we're going to add the image specifier for that machine block. And we're telling it to use OpenFoam GCP. So that all looks good. I'm going to go ahead and update that partition. And of course, I'm running into an issue. Oh, right. There's an issue we have with name overlap. So if I have the name overlap in the machine type with the controller and with that machine, it caused some issues. Let me go ahead and just fix that. Sorry about that. Now, you practice this multiple times, but you always run into these problems again. So I'm just going to change the name of that machine block to N1 standard 16. Just going to name it the same thing as the machine type. All right, let's preview that again, and let's update partitions. So now we're doing okay. So now if I run sinfo, you see now I've got OpenFoam. The node list is now set as N1 standard 16. No big deal. It's just a name change. Just a small bug that we're actually working on at the moment. Okay, so the other thing we need to do is just go ahead and quickly set up the Slurm accounting. And now if you were here for the tutorial from a couple weeks ago, you already know how to do this, but I'll quickly walk you guys through this. So again, we're going to do cluster services. We do have a set of commands underneath what's called sample. So you can get examples of different like Slurm account blocks, partition blocks, mount blocks, all that stuff like that for your cluster config. So we're going to go ahead and sample Slurm accounts, and we're going to append that to config.yaml. So let's open that up. I'm going to grab Slurm accounts from line 44, just paste it down below, remove those brackets there. And then we're just going to configure this. So I want to have the allowed partitions be OpenFoam, so that I can submit jobs to the OpenFoam partition. I want to set the name of this Slurm account to, let's say, CFD. This could be for a group of people who are doing computational fluid dynamics. And I'll set the name of the users who are going to submit. For me, it's just Joe. And then we're done there. So we're going to run through the same thing. Instead of updating partitions, we're going to update Slurm accounts. So let's go ahead and bring that cluster services update command back up. All right. And then we will get rid of that preview flag. Cool. So that's just about it on the cluster configuration side. There's one comment I just need to make is if you're on version 2.5.0 or previous, There's one change you do need to make in the compute startup script file. This is a patch that's actually it should be coming through tonight, so by tomorrow, if you're doing this, you won't need to do this step. But just go ahead and navigate to the apps, Slurm, scripts directory, open up that compute startup script. This is good to point out to you too, is if you ever needed to customize what's done during the boot of the cluster, just go ahead and hop in here and you can make any changes you want. So we're gonna just go ahead and remove that line where we're adding opt to the FS tab for the compute node. So just go ahead and delete that line that had opt in it. So again, we're just deleting that line that mounts opt, and that resets that. Now we're done. Now we're done with the setup. We're going to go ahead and hop out of this node, and then we're going to go ahead and log into the login node. So from the Compute Engine UI, you can see the IP address. You can copy it, or again, if you're in the Compute Engine UI and you just want to SSH in from there, just click that SSH button. That'll get you right in. So I'm just going to go ahead and use that. Okay. So cool. All right. Oh, right. There's one other file. I should have. I'm going to hop back out of this login node. There's one other file that's actually useful for you here in the examples. So if you're on your local system or wherever you have this custom image bakery repository cloned, go under that examples OpenFoam subdirectory. We have an OpenFoam.slurm file. So this is an S-batch file that you can use to run the demo that we're going to do today. So I actually just need to SCP this guy up to our cluster. Let's go ahead and do that. And copy that IP address. All right, so we'll copy that up there. Now let's go ahead and SSH back in to that login node. Great. All right, so OpenFoam.slurm is there now. And I mean, really from here, we're just gonna go ahead and run the batch job, and then I'll walk you through what that batch job's actually doing as those nodes are coming live. So I'm gonna run sbatch OpenFoam.slurm. I guess the first thing we need to do is make sure that the account is set, the account name is set to the account that you're using in your Slurm accounting. I set mine to CFD, and make sure that partition's set correctly. And you can see it, if you're following along with exactly what I'm doing here, you should be good to go. But just double check that if you're on your own system and you did something differently. So just go ahead and run sbatch OpenFoam.slurm. Take a look at SQ. We've got a node configuring for us. Now if I refresh the Compute Engine UI, you now see I've got a compute node that's spinning up on the fly, which is kind of nice. This process to create that node can take anywhere from 30 seconds to 2 minutes. But essentially what's going on in the background is the controller daemon has issued a request to create the node, and it's launching it with that OpenFoam GCP image on it now. So let's take a look at that batch script so you get an idea of what's actually going on in this run. So at the very top, we have two files that we need to source so that the OpenFoam and MPI run commands are in our path. So you just run source on these two files here. That's just what's baked into the image for us. And I do like a sanity check to make sure that we are actually using the GCC9, or the GCC9 is what's available in our current path. So once you actually source the OpenFoam directory, you do get a ton of environment variables available for you. One of them is foam tutorials, so you can easily access any of the tutorials that come with OpenFoam. So here what we're doing is we're just copying the row simple foam airfoil Naka 012 examples. This is just flow past a compressible flow past an airfoil. And then the only thing I've done to modify this is just add a domain decomposition file, the decompose bar dict. Basically, we're just splitting this into the number of Slurm tasks subdomains. So in this case, if I go up to the top here, you see I've got n tasks is set to 8. And so this will basically set up the decompose bar dict to use eight domains, one for each MPI rank that we launch with. I do take advantage of the run application wrapper script here to basically run the mesh generation side for block mesh and then the extrusion, and we run decompose par, and then down below you see we're just doing MPI run on row simple foam, so we run in parallel, and then at the very end of that job all the output files are stitched back together. And this is really all we're going to end up doing today. Is I just wanted to get you off the ground with running OpenFoam. So, you know, in a couple weeks, what's going to happen is we're going to have a little tutorial on using ParaView, and we're going to look at doing some post-processing of this output with ParaView on GCP. So let's take a look at what's going on with this job. Looks like we're still configuring here. See what's happening. So if you hop in here on the console, you can take a look at some of the metadata here. So the deal is, yep, we're using OpenFoam GCP. And if you ever wanted to check status of some of these compute nodes, you could just hop through on the serial port logging. So let's see what's going on. Now we're running. And you can see now I've got this aerofoil Naka 012 directory now in my home directory. So everything's been moved over. And then we've got this OpenFoam 2.log file. So if you run tail -f on that, you can kind of track what's going on during this run. It looks like it's just now getting through the initialization here. Yeah, now we're actually running through the simulation. So let's hop out of here. Let's go check out what's going on inside the aerofoil directory. And you see we got pretty typical stuff here. So it looks like the domain decomposition's already done. So we have output coming in for each MPI rank, and shortly here I imagine we'll be getting the other time series output or the other fluid state output from that run. So let's keep an eye on that guy there. But that's essentially it. So I guess if I were to put this in the simplest way possible, all you got to do is launch that auto scaling cluster, modify that cluster config so that the compute partition is using the OpenFoam GCP image we provided for you. And again, remember that was in that cluster config. If you're down in the compute partitions under the machines, all you had to do is add this block here for the image, projects fluid cluster ops global images OpenFoam GCP, and then you're good to go. So next time, I guess we'll go ahead and just update here through the slides. I'm going to let that keep running, but while that's running, just to give you a few resources here, if you did need help getting quickly started with the auto scaling cluster, we have a lot of documentation on our site. Just check out help.fluidnumerics.com/slurmgcp. We also have code labs up there that will show you how to spin up the cluster, and we'll go into a little bit more detail about some of those configurations you saw on that marketplace page. I will say, just keep an eye out. In the next couple weeks here, we are we're preparing a click to deploy solution for you with OpenFoam, so that you don't have to even do these customizations. You'll be able to launch just directly from marketplace. So in a couple weeks from now, we'll be redoing this tutorial again with an easier solution. But if you wanted to get off the ground running today, this is what you can do. Of course, if you need any help with this, just reach out to us at fluidslurmgcp@fluidnumerics.com. So the upcoming schedule we have for you guys. So we're going to be redoing this tutorial again tomorrow at 9 a.m., next week at 4, and next Friday at 9 a.m. And then following up with that, we're going to show you how to actually connect your HPC cluster, your auto scaling HPC cluster, to a ParaView client on your local system, so that you can use the HPC cluster as a ParaView render farm running PV server on the back end, and we'll be visualizing a lot of the output we had today. Let's take a look. Looks like that job's done for us there. And if I look underneath that aerofoil demo here, now we've got a full database of output for flow, pass, and airfoil. So thanks for tuning in. I hope you guys enjoyed this and found it quite useful. Feel free to share this with any of your colleagues who are looking forward, who want to run OpenFoam on Google Cloud. And of course, if you have any questions, feel free to post them in the chat. I'll hang around here for a little bit and see what I can do to answer any of your questions. Again, thanks for joining, and we'll see you guys next time.